Another theorem says that a polynomial p of x has a 0, x equal to a, if and only if the polynomial has a factor x minus a, which means that we can write the polynomial as x minus a multiplied by some other polynomial, q of x. For example, this polynomial, it has a 0, x equal to 2. And that means, according to this theorem, that we must be able to write this as x minus 2 times some other polynomial. And since this is degree 1, this is degree 2 polynomial, this must be degree 1 polynomial. And you can check that this polynomial will work. So if you multiply these two, you will get this one. And inversely, if you have the polynomial written like this, it's obvious that 2 is a 0 of this polynomial. More generally, if we have a polynomial that we can write as this, how can we find this polynomial here if we know this one? Then you can find q of x by doing a polynomial division, and we will see an example of that now. The procedure of doing a polynomial division is very similar to doing a division algorithm. So let's first look at a normal division algorithm. If you want to repeat the division algorithm, you can look up here. But we will do now one. So let's take this one. First we see that 56 goes in 131 two times. So 2 times 56, that's 112. Then we subtract, then we see we get 19. Then we move down the next digits. And now, how many times does 56 go in 190? Then we have 3 times. So 3 times 56, that's 168. And that's 22. And then we move down the 4. And then finally, you see that this goes 4 times. This then becomes 224. And then we get the answer here. Now we want to do similarly, but using polynomials instead. So let's take this as an example. So let's say that we want to divide this by this. Then we first have to check how many times does this go into x3. Then the highest degree we can have here is x2. And if we now multiply these two, then we see that we get x3 and we get 2x2. And here we get minus. But now, if you remember the division algorithm, we want to subtract this. So subtracting this, we have to change the sign here to plus. So this was minus, but we changed it to plus. Subtracting these, we get these cancel, and this becomes 4x squared. Then the same as in the division algorithm, we need to take this down here. Then we repeat. How many times does this go into this? We only look at the highest power here of x. We can put 4x, so 4x times x, that's 4x squared. And then 4x times minus 2, that's minus 8x. But we need to change sign, so this becomes plus, and this becomes minus. This cancel, and now this becomes 3x. And then we move down to 6. Finally, how many times does this go into this? If you look at the highest here, then we have a 3. So 3 times x, that's 3x. Then we have minus. And 3 times minus 6, that's minus 6, changing it to plus, since we subtract. And now we see that we have 0 and nothing left in the polynomial. That means that this is the answer. This is the quotient of this division. So that means that we have this can be written as this. So that polynomial times that one is equal to that one. Then we have found what we call the polynomial here, q of x. The fact is that if you have a polynomial of any degree, you can always write it as a product of polynomials with degree 1 or 2. And now we will see how that is done. So we show it using an example. Assume that we know that this is a 0 to this polynomial after we have tested some numbers. According to the theorem we saw, then we know that we can write this polynomial as x minus 1 times some polynomial. And this polynomial we can find by polynomial division. So let's do that now again. How many times does this go into x3? Then we have x squared. Since x squared times x, that becomes x3. And then we subtract that. And this times this becomes minus x squared. And then we subtract and it becomes a plus. Then we become 2x squared. And these cancel. Moving down to 5x. Then, how many times does this go into 2x squared? Then we can write here 2x. Since 2x times x, that is 2x squared. And then we subtract. 2x times minus 1, that's minus 2x. And then we subtract, so it becomes plus. So this is minus 3x. And then moving down finally, the 3. How many times does this go into this? The answer is minus 3. Minus 3 times x, that's minus 3x. But plus, since we subtract. Minus 3 times minus 1, that's plus 1. But we subtract, so it becomes minus 3. And then we get 0, which means that this is the quotient. This is the polynomial here. So now we can write this as this. This is a second degree polynomial, so we know how to find the zeros of that one. And if you've forgotten that, you can look up here. Solutions here are given by this formula, where a, b, and c are those numbers here. And putting in b equal to 2, a equal to 1, and c equal to minus 3 here, then we first get this, which simplifies to this. And this, which finally gives us two solutions. Minus 6 divided by 2, minus 3, and plus 2 divided by 2, 1. So we see the solutions are minus 3 and 1. That means the zeros for this one are minus 3 and 1. And that means that we can write this as x minus the first one, and x minus this one, so minus the zeros. So this one can be written as x minus 1, x minus 1, x plus 3. So we see now we have written it as a product of first degree polynomials. If it would have been turned out that this has no solutions, then we have been left with a second degree polynomial here we couldn't factorize. So then we would have a first degree times the second degree. But you can always write it as a product of first degrees and second degrees. More generally, if we have a second degree polynomial or quadratic function, and it has zeros x1 and x2, then we can always write it in this way. Like this if the zeros are not equal. And like this if the zeros are equal. And if there are no zeros, you can't write it as a product of first degree polynomials, unless you go with complex numbers, but we don't study that here. We will now see an example of how to solve an inequality with a polynomial. So let's say we want to find out when this polynomial is greater than 0. Then we can use trial and error just to see if we can find one 0 to this one. Then you will find that 2 is a 0 to this one. And that we already saw here, because we studied that polynomial, and we saw that this was a factor. That means that 2 was 0. So after having found this, we know that we can write this polynomial as x minus 2 times some polynomial here. And this polynomial we found earlier, it was this one. So after doing a polynomial division, we find this polynomial here. Then we only need to factorize this. Then again, using ABC formula, then we get this one after putting in a equal to 1, b equal to 4, c equal to 3. And this can be simplified to this, and further this. And since the square root of 4 is 2, we'll get this. So we have two solutions. Minus 2 divided by 2, that's minus 1. Or minus 6 divided by 2, that's minus 3. So we have our zeros x1 equal to minus 1, x2 equal to minus 3. Then we know that you can write this one as this, according to the theorem we just saw. And here a is equal to 1, so there's nothing multiplying in front. But in our case, this is minus 1 and minus 3. So we will get and finally we can write our original polynomial as x minus 2 times these two. So we have this product. If, for example, we wouldn't have any zeros here, then we just have to keep our second degree here and continue as it follows. Then the next step is just to solve this using the following technique. So we write first one number line for x, then we write one number line for each of the first degree polynomials, or second degree if we have that. And then in the final row we write for the complete polynomial. We see here that we have zeros at 2, minus 1 and minus 3. So let's put that into the x-axis as interesting points. So we draw down here, so we have minus 1, 2 and minus 3 on all lines. And let's use red to symbolize plus and blue to symbolize minus. So x minus 2 is larger than 0 when x is larger than 2. So it's positive here. And it's negative here. And it's 0 here. X plus 1 is positive for x larger than minus 1. And negative for x less than minus 1. And 0 here. And x plus 3 is larger than 0 for x larger than minus 3. And negative for x smaller than minus 3. And 0 for x equal to minus 3. Now we have this product of three numbers, three positive numbers, then this product must be positive. Here we have two positive numbers and one negative, and then it becomes negative. Here we have two negatives and one positive, so that becomes positive. And then finally negative after doing three negatives. and in between here 0, since one of these are 0. Now we wanted to find out when this is larger than 0. So that means it's here and here. So we have the solution that x should be larger than 2, or x in the interval between -1 and -3. So these are the solutions to the polynomial.